Hello once again. Right now we are going to look at proteins and fats during exercise. And this is our fourth lecture in sports nutrition. Protein turnover. The body continuously degrades and synthesizes proteins with a net protein deposition when synthesis exceeds degradation. The total protein turnover in the body is about 350 grams per day. Due to amino acid reutilization, the dietary protein requirement is lower, around 70 grams per day. And different proteins have varying half-lives, with the entire body protein turnover occurring roughly every 27.6 days. Protein deposition. This is the highest during lactation, but it levels off at around 3 grams per day in most situations. Mitochondrial proteins rather than the myofibrillar proteins mainly influence the body composition of endurance athletes. The states of the body. In the absorptive states, after eating, there is a surplus of energy which results in anabolic processes like protein synthesis. In the post-absorptive state, however, that is the no nutrient influx, glycogen, fats, and proteins are broken down, which leads to protein breakdown. Protein synthesis can be measured using amino acid tracers labeled with stable isotopes. Essential amino acids are typically required to stimulate protein synthesis, and they also play a central role in this process. Resistance exercises. Resistance exercise stimulates protein synthesis with a peak occurring after exercise. The post-exercise increase in protein synthesis is most significant during the absorptive state. Protein ingestion after resistance exercise will further enhance the fractional synthesis rate. The mammalian target of rapamycin is a key regulator of protein synthesis and is activated by various factors that include exercise, feeding, IGF-1, and leucine. Protein supplementation. This may benefit muscle mass gain during resistance training, and there is a considerable individual variation in the response to protein supplementation. On average, protein supplementation has a small positive effect, but its effectiveness varies among different individuals. Muscle adaptation. Muscle exhibits plasticity and adapts to different types of exercise. For example, endurance exercise leads to increased mitochondrial content and function. Strength and sprinter training promote hypertrophy through the mTOR pathway. And also oxygen consumption in exercise physiology. The importance of fats. Fat is a vital fuel source during endurance exercise. The capacity to oxidize fat is correlated with performance. Limitations of high-fat diets. The body fat stores are abundant. However, the high-fat diets can limit high-intensity endurance exercise capacity and performance. Sparing carbohydrates through increased lipid oxidation can also benefit high-intensity exercises. The lack of specific fat intake guidelines. There are no specific fat intake guidelines for athletes, and so they typically follow the general health guidelines. The nutrient availability and energy stores can also influence training adaptations. Fat oxidation and training. Regular endurance training enhances lipid oxidation and reduces sympathetic nervous system activity. Trained athletes will tend to rely more on fat oxidation and less on carbohydrate oxidation. This adaptation is associated with increased mitochondrial volume and enzymatic changes. As exercise intensity increases, reliance on carbohydrates as a fuel source becomes greater, and this reduces the fat oxidation. The point of maximal fat oxidation, this is known as the fat max, occurs at about 62% of oxygen volume or maximum oxygen volume. The trained athletes may have a slightly higher fat max. The nutritional strategies for improving fat oxidation. 3 primary approaches have been introduced to increase fat oxidation. And strategy number 1 is boosting fat oxidation. Fat burners like caffeine, carnitine, MCT or MCFA, and ketone bodies can be used, but their effectiveness is limited in improving fat oxidation during exercise. The second strategy is fat adaptation. At low carbohydrate levels, high-fat diet is used to promote fat adaptation, and this results in a metabolic adaptation but may reduce high-intensity exercise capacity. And the third strategy is training with low carbohydrate availability, and this is also known as train low or compete high. This approach involves improving fat oxidation at lower training intensities to enhance overall performance. Boosting fat oxidation with MCFA. These are the medium chain fatty acids, and they are absorbed and utilized differently compared to the long chain fatty acids, the LCFA. The MCFA have a more glucose-like behavior and can be quickly used for energy. And research shows no significant performance benefit from the supplementation of the MCFA. Caffeine as a fat burner. Caffeine has metabolic effects but is not an effective fat burner during exercise. Its primary benefit is a central effect on the brain that reduces fatigue perception. Then the L-carnitine supplementation. L-carnitine is part of the carnitine shuttle system that transports the low-chain fatty acids into the mitochondria. Oral carnitine supplementation does not significantly affect muscle pulls or glycogen breakdown, and its impact on exercise performance is yet to be conclusive. Fat adaptation involves a low carbohydrate, high fat diet, and initially it increases reliance on fat oxidation while at the same time reducing carbohydrate metabolism. This adaptation improves endurance exercise performance in the short term. The long-term effects of the long-chain fatty acid or high-fat diet. In the long run, we find that the long-chain fatty acid diets can reduce exercise capacity and performance. And a study tested whether a high carbohydrate diet could rescue this effect after 7 days of low-chain fatty acid diet. Even with 1 day of carbohydrate restoration, you find that the adaptive response to the long-chain fatty acid diet persists. Improved lipid oxidation was also observed after 3 days. Metabolic changes in fat adaptation. Fat adaptation reduces reliance on carbohydrate metabolism, and it downregulates key enzymes in the carbohydrate metabolic pathway, while upregulating key enzymes in the fat oxidation pathways. These metabolic responses are supported by adaptations in skeletal muscles. So proteins and fats are also very important during exercise, as the fats are used mainly when the carbohydrate stores are down, while the proteins can only be used as the last resort when there are no fats and carbohydrates. Thank you.